All right, today should be Wednesday, November 18th, B day at home today. I apologize. Today is probably going to be a really long video. So bear with me as we go through it. There's just a lot of stuff in today. Okay. So picking up on 6.2, day 2. All right. So Ms. Pittybag, she's back again. So she finally decided on a permanent employee wages, which are randomly assigned using a probability distribution X, which is given below. Additionally, at the end of every year, she gives her employees an hourly raise. The bonuses are assigned randomly according to probability distribution Y, given below. We're going to assume that X and Y are independent. So from this probability distribution, move this over, okay, we're going to calculate the mean, the variance, and the standard deviation, okay? So by hand, let's calculate one of these by hand, all right? So remember, to find the mean, for the weighted mean, we would take 9 times 0.3 plus 12 times 0.45 plus 15 times 0.25. Okay, so that would give us the mean of about 11.85. Okay, so to calculate standard deviation by hand, standard deviation would be the square root of the probability. So just looking at this first one here first, the probability times the distance from the mean squared. So data value, X value 9 minus the mean squared. So that would have been 9 minus 11.85 squared, and then times the probability that goes with it. So then we do that for the next 3 columns. So we'd have probability times distance from the mean squared plus 0.25 times 15 minus 11.85 squared. Okay, find the square root of all of that. That would give you the standard deviation of 2.22. Remember, the variance is the standard deviation squared. So square that. We should get the variance. Okay, so that is how you would calculate the mean and the standard deviation and the variance by hand. Okay, I show that to you because you're going to have to do one of those on your upcoming quiz. For the next couple, I'll show you how to do it on your calculator. All right. So in this next one, so here is the distribution of Y with the corresponding probability. So you could go through, calculate those by hand like we did previously, or you could enter the Y row into L1, enter the probability row into L2, and then do one var stats, L1 comma L2, or if yours brings up the frequency list, L2 would be your frequency. Hit enter, and then that should give you the mean, the variance, and the standard deviation. Okay, so you should get a mean of about 1.60, variance of about 0.841, and a standard deviation about 0.917. Okay. All right, next one. Let n equal the new hourly wage for the upcoming year. So this would be X plus Y. What are all the possible new hourly wages for the new year? So here you're going through and just combining what are the different ways that you could combine the 9, 12, and the 15 with the 1 and the 3. Okay, so all possible new hourly wages. We could get 10, 12, 13, 15, 16, and 18. Okay, what is the probability of an employee being assigned a $9 wage and a $1 raise? Well, probability of 9 and 1 would equal the probability of 9 times the probability of 1, which would be probability of 9 from up here would be 0.30. So 0.30 times the probability of 1 from this table times 0.70 would equal 0.21. Okay. All right. Complete the table below for the probability distribution of n equals x plus y and find the mean and the standard deviation. Okay, so our end row here is just our possibilities. So the 10, 12, 13, and so on. Okay, so we have 10, 12, 13, 15, 16, and 18. Okay, so to get the probabilities, like probability of getting a 10 would be what we calculated here in part B, because this would be a $9 wage and a $1 raise. So that would be the $10. So that would be the N. So that would be the 0.21. Okay, so that's how you'd have to go through this chart to fill in the missing probabilities. Okay, so to get a 12, that would be combining the $9 wage and the $3 raise. So that would be 0.3 times 0.3. Okay, so to get the 12 one would be 0.3 times 0.3. So 0.09. To get the 13 would be 0.45 times 0.7. So we get 0.315. To get 15, 0.45 times 0.3. So 0.135. $16 wage, 0.25 times 0.7. So we get 0.175. And then the 18, 0.25 times 0.3. We get 0.075. All right, so now if we took this table, again, L1, L2, one of our stats, we'd get a mean of 13.45, a variance of about 5.77, standard deviation of about 2.402. Okay, so if n equals x plus y, complete the following in terms of x and y. Well, the mean of n, the mean of this new data here, would be the mean of x plus the mean of y. Okay, we looked up here. We took the original mean with the x, the original mean with the y, added those means together, we would get our new mean of x plus y. Okay, because we were adding the wage and the raise. We were just adding them together. Okay, the standard deviation of n would be the square root of the standard deviation of x plus the standard deviation of y. Okay, so variance would just be adding the variances together. Okay, so notice you can add means. Okay, means we can add together to get the new mean. Variances, add 4.93 plus the 0.841, add the variances to get the new variance, but you cannot add standard deviations. So if we wanted to use this previous data for the variances to get the new standard deviation down here, you could add the variances together and then take the square root of the variance to get the new standard deviation. Okay, so I know that was a lot, but we're still not done. Okay, so independent random variables. If knowing whether any event involving X alone has occurred tells us nothing about the occurrence of any event involving Y alone, and vice versa. Okay, independence. For the mean of the sum of random variables, so in general, to get the new mean, we can add the previously known means together. To get the new variance, we can add the variances together. And to get the new standard deviation, you would add the new variances together, or the variances together, and then take the square root, which would give you the new standard deviation. Okay, you can, to get the new mean, if you were subtracting, you could subtract means to get the new mean. Variance, we still add the variances together to get the new variance. And to get the new standard deviation, we still add the variances together and take the square root of that result to get the new standard deviation. Okay, so a lot of formulas there, a lot of formulas to know. All right, so we're going to go through a couple long ones. I might just go through 2 of these in class since they're going to be pretty long. All right. So suppose that a certain variety of apples have weights that follow a normal distribution with a mean of 9 ounces and a standard deviation of 1.5 ounces. Okay. If bags of apples are filled by randomly selecting 12 apples, what is the probability that the sum of the weights of the 12 apples is less than 100 ounces? Okay, so for this one, we cannot just right away do normal distribution, do normal CDF, because we're not talking about a single randomly selected apple. Okay, we are talking about a probability that the sum of the weights of 12 apples is less than 100 ounces. Okay, so starting off with, we got to assign what our variable is going to represent. So we could say, let X equal the weight of a randomly selected apple. Okay, then X sub 1 would be equal the weight of the first randomly selected apple, and so on. Okay. So we are interested in the total weight. Okay, so we want the total weight which would equal x1 plus x2 plus x12, because the total is the sum of the 12 independent normal random variables. Okay. So T follows the normal distribution. So we'd want to find the mean of T, which would be the mean of x1 plus the mean of x2 plus ... plus the mean of x12. Okay, so if each of the means was 9 from up here, we'd have 9 plus 9 plus 9 12 times to get a mean of 108 ounces. Okay, so then the variance, okay, so this would be, sorry, so we'd be finding the standard deviation, because I didn't include the squared here. So the standard deviation would be the square root of all of the variances added together. Okay, so we'd be taking the original standard deviation, which was the 1.5 ounces. Since we can add variances, not standard deviations, variance would be the square of the standard deviation. So that's why under here, to get the new standard deviation, it would be equal to the square root of all the original variances added together. Okay, so if the original standard deviation not mean to erase all of that. Okay. So if the original standard deviation was 1.5, that means the variance would be 1.5 squared. So we would add 1.5 squared together 12 times. So that would end up equaling the square root of 27, which would equal 5.2. Okay, so that means the new standard deviation is 5.2. The new mean is 108. We want to find the probability that X is less than 100 ounces. Okay, so now once we have calculated the new standard deviation, the new mean, we're looking for X is less than 100 ounces. So now we have the numbers that we need to do. You're using your calculator, normal CDF, lower bound, since we're less than 100, negative 1E99, upper bound 100, mean 108, standard deviation 5.2, which would give us 0.062. Okay. So then for the interpretation part, so I'll backtrack a little bit. Once you have this information, if you didn't want to use the normal CDF, you could have found the Z-score and used table A. Okay. So interpretation, there is about a 6.2% chance that 12 randomly selected apples will have a total weight of less than 100 ounces. Okay. So the new part here for chapter 6 is obviously just transforming the original means, transforming the original standard deviations to get a new mean, to get a new standard deviation, to then use normal CDF. Okay. All right. Okay, at a speed dating event, women sit in a circle and men spend about 10 minutes getting to know a woman before moving on to the next one. So suppose that the height M of male speed daters follows a normal distribution with a mean of 69.5 inches and standard deviation of 4 inches. And the height F of female speed daters follows a normal distribution with mean 65 inches and standard deviation of 3 inches. What is the probability that a randomly selected male speed dater is taller than a randomly selected female speed dater with whom he is paired? Okay, so if we define the random variable D would equal M minus F, right? So that's going to represent the difference between the male's height and the female's height. Okay, because D is the difference of two independent random variables, D follows a normal distribution with, okay, so now it's time to do some calculations. Okay, so the mean difference, so U of D, would equal the U of M minus the mean of F. So mean of male was 69.5. Mean of female was 65. So subtract those, and then the mean of the differences would be 4.5. Okay. Standard deviation of the difference would equal the square root of the standard deviations squared. So we'd want to add the variances underneath the square root. So we'd have O of M squared plus O of F squared which would equal the square root. So since the standard deviation of males was 4 squared, standard deviation of females was 3 squared, so square root of 25, which would equal 5. Okay, so that means the standard deviation of the difference would come out to be 5. So our goal is to find so if our goal, coming back to the question, is to find what is the probability that a randomly selected male speed dater is taller than the randomly selected female speed dater, we would want to find what is the probability that the male height is greater than the female height, which in terms of what we're doing here with the mean and the standard deviation of the difference, okay, we would want to find what's the probability that the difference is greater than 0. Okay, so using technology, using your calculator, you could do normal CDF, lower bound 0, greater than 0, lower bound 0, upper bound 1E99, mean 4.5, standard deviation 5. Okay, so from that, we should get 0.8159. Okay, so again, you could take this mean, take this standard deviation, take this data value. You could get the z-score, use table A, either way. So once we get our probability, come back and actually answer the question. So there is about an 82% chance that a randomly selected male speed dater will be taller than the randomly selected female speed dater with whom he is paired. Okay. All right, let's do another one. If you're good after those two, you can just bow out of this video. Otherwise, we'll power through another one here. Okay, so Mrs. Starnes likes between 8.5 and 9 grams of sugar in his hot tea. Suppose the amount of sugar in a randomly selected packet follows normal distribution with a mean of 2.17 grams, standard deviation of 0.08 grams. So he's going to select 4 packets at random. What's the probability that his tea will taste just right? Okay. So we got to assign what our variables are going to be. So let X equal the amount of sugar in randomly selected packet. So then X sub 1 would be the amount. Draw. So then X sub 1 would equal the amount of sugar in packet 1, and so on. Okay, so we are interested in the total amount of sugar. So total sugar, which would equal x1 plus x2 plus x3 plus x4. Okay, so because t is the sum of 4 independent normal random variables, t is going to follow a normal distribution. So u of t would equal the mean of x1 plus the mean of x2 plus the mean of x3 plus the mean of x4. Okay, so if we added all those together, so mean from up here is 2.17. So 2.17 plus 2.17 plus 2.17 plus 2.17 would equal 8.68. Okay, now for the standard deviation. So the standard deviation of t would be the square root of x1, x2, x3, x4. Okay, so we would be taking the square root of adding the variances together. So if the original standard deviation was 0.08, we'd want 0.08 square root of 0.08 squared. 0.08 squared plus 0.08 squared. Okay, standard deviation would come out to be 0.16. Okay, so we have the new mean of 8.68. We have the new standard deviation of 0.16. Okay, so if he likes, so he likes his tea with his sugar grams between 8.5 and 9 grams. Okay, so what we'd find now is using their calculators, if you wanted to, normal CDF, between 8.5 and 9. So 8.5 for a lower bound, 9 for an upper bound, mean 8.68, standard deviation 0.16. So that would give us 0.8470. Okay, you could, again, use these data values, the mean and the standard deviation, to get the z-scores and use table A. All right. So, interpretation, there is about an 85% chance that Mr. Starnes' tea will taste just right. Okay. All right. That was a lot. Get pretty complicated. Hopefully by example 3, if you continued on with me, you kind of got the gist of how these go, of taking the original mean, original standard deviation, getting the new mean, getting the new standard deviation, and then using the normal CDF, or getting the z-scores and using table A to get your percentage, i.e. probability. All right, that ends 6.2 day 2. Tomorrow in class, we will be working on the 6.1, 6.2 quiz review. So if you had some questions from today, you'll have time tomorrow in class to ask those questions. So a long time in between quiz review and quiz next week.